It says, if the square of x plus 3 equals 121, what is the sum of the two possible values of x? Let me ask you a question. A very easy question, perhaps, for many of you. Y squared equals 9. What is the solution to this equation? Y equals what? What is the solution? If y squared equals 9, what is y? Any idea? No? Take the square root? Okay, Luciana. Good, you are focusing on the methodology. It is true that in order to get closer to the solution, you need to take the square root on both sides. Okay, great. Let's take the square root, and this must be equal to the square root of this. And so, what is the square root of this? What is actually the square root of y squared? Some people do this, take a look. They say, this is simply y. They say this, cancel this, and you get y. And the square root of 9, they say, oh, the square root of 9 is plus or negative 3. And so, from this, you get to the two solutions. What is incorrect in this reasoning? There is a simple mistake here. I don't know if you can see it or not. First, the $1 million question. This expression, a square root of a, can be positive or negative, or can be both. And why? What's your response? Did you know that the square root is a function? Let's say f of a equals the square root of a. How do we graph this function? This function is half of the horizontal parabola. Let's say this is a, this is f of a. What is the square root? Is this. This is the square root curve. What does it mean? First, that the square root can only be applied to a positive number. What else does it mean? That the result of the square root can only be positive. Okay? If this is a, this value here is f of a. The square root is always a positive number, mathematically speaking. So, how come the square root of 9 can be negative 3? Impossible. The square root of 9 is only 3. Okay, I understand, teacher, say some people. The square root of 3 should be 3. Okay, according to this mathematical definition of the square root function, and from where the operator the square root comes, the square root of any positive number should always be another positive value. So how come the square root of y squared is only y? So where does the negative 3 come out as a solution? Well, it's simple. This here is never y only. Please don't forget this fundamental identity. Will come back in a further lesson about this equivalence. This is a universal equivalence. The square root of any algebraic expression z squared. Look, this is different from this, It's not this. The square root of z up to 2. No. We're not talking about this. We know this is always z. Now we're talking about the square root of a square of something. This is always the absolute value of z, all right? It cannot be any other way. Why? Why? Think about this for a moment. You know that this expression is always positive. As such, it has a square root, because only positive numbers have a square root. The square of z is always positive, but what about z? Do you know the sign of z? Do you know whether z is positive or negative? You don't. Because you don't know, imagine that z is a negative number, and if you say the square root of z squared is simply z, being z negative, that would mean that you are affirming that the square root could be a negative number, and that's impossible. Impossible because of this definition. The square root can never be negative. So we cannot simply say that the square root of the square of z is simply z. You cannot just cancel the radical and the exponent too. No, what you need to do is to be aware that this number is positive, the square of z, but z itself could be positive or negative. Since the square root always has to be positive, then you take absolute value of z in order to positivize z. So that's the way this algebraic identity works. The square root of any square of something is always the absolute value of that something. So, applying this identity in our basic equation y squared equals 9. What is the square root of y squared? It's simply the absolute value of y. The absolute value of y is equal to 3. But what does the absolute value mean? It's the distance of y to 0 on a number line. For example, 0 is here. Imagine y is here. Okay, this distance between 0 and y is always positive distances. This is the absolute value of y. And what happens if y were on the other side of 0, that is to the left of 0? Y here. Okay, again, this distance between y and 0 is the absolute value of y. So, the absolute value is the positive distance between any number and 0. If the number is positive, that is to say, if y is a number greater than 0, then simply the absolute value of y is simply y, and y equals 3. But if y is a negative number, then the distance between y and 0 would be the inverse additive of y, that is to say, negative y. If y is negative, negative y must be positive, right? Yeah, so negative y is what would be equal to 3. So you have y equals 3 or negative y equals 3, which means actually that y equals negative 3. So these are the two solutions of this equation. This is the correct sequence of reasoning, okay? Don't say that you take the square of y squared, that is y, and the square root of 9 plus or minus 3, because that doesn't exist. Maybe it's a trick for solving fast, but conceptually it's wrong. So be careful. Now, what is the sum of the two possible values of x? If we understood this explanation, then what would be the answer to the question? We can simply solve this in a very simple way. Take a look. If I take the square root of this, in order to simplify, what do I get? I get the square root of 121. What is the square root of the square of something? That is the absolute value of that something. And the absolute value equals the square root of the other number, which is 11. So they are telling us that the absolute value of x plus 3 equals 11. That means if x plus 3 is positive, then the absolute value of x plus 3 would simply be x plus 3, the same number, and this would equal 11, from which, of course, x would be 8. But if x plus 3 is less than 0, which may be possible because we don't know x yet, then the absolute value of x plus 3 would be the inverse additive of x plus 3. That is, x plus 3 multiplied by negative 1. And this would be equal to 11. From this, you can clearly see that x plus 3 would be negative 11, and x would be negative 11, take away 3. So, the value would be negative 14. The two solutions, 8 and negative 14, what is the sum? 8 minus 14, you have negative 6 for an answer. So that's the answer to this question. Don't forget this, whenever you have to solve a quadratic equation like this. Okay, what is another possibility for solving the equation given? You can simply say x plus 3 squared equals 121, so x plus 3 equals plus or minus the square root of 121, or plus or minus 11. If you equate x plus 3 to positive 11, you get one solution. If you equate x plus 3 to negative 11, you get the other solution. That's also a practical way to do it. But you know, the procedure shown here is actually conceptually correct from a mathematical point of view. You need to be clear about this, otherwise you will be making mistakes when working with squares of algebraic expressions.